Formula says that 1 over the radius squared, that's the radius of the end circle, is equal to the sum of the squares of the reciprocal of the tangent line. See, so 1 squared plus 1 over 4 squared plus 1 over 2 squared. That's it. So which is equal to 1 plus 1 over 16 plus 1 over 4, which is LCM is 16 plus 1 plus 4. So I have 21 over 16, which implies that r squared is now 16 over 21. Therefore, the area of the end circle is equal to, area is pi r squared, so we have 16 over 21 pi. So the answer is option A. So it's very fast. So let's prove this formula. So we have something similar to what we are given. So, but before then, there are 3 theorems we need to know that will help us to solve this. Look at this diagram. From this, you know that the length of tangent from an external point are equal. So this and this are equal. As you can see, this is the radius. We have proved that is the radius. So by congruent triangle, so we have 2 congruent triangles. As you can see, this triangle and this triangle are the same. Since they have radius, common hypotenuse, therefore this length must be the same. And also here, the length of common tangent, you call it common external tangent of 2 circles, is always equal to square root the product of their radii. Yes. So that's it for anything. I've proved it before, so we don't need to waste time. And again, area of a circle inscribed in a triangle, that the area of triangle ABC is related to the radius and the semi-perimeter of the triangle as Rx, where x is the semi-perimeter. Semi-perimeter meaning the sum, that is area. Since this is this, implies that the radius is the area of triangle ABC over the semi-perimeter. Euron's formula: the area is always square root of x times x minus a, x minus b, s minus c over x. Yes. So that's it. Meaning that if we square both sides, that's r squared. Now if we square, so we have x minus a, x minus b, x minus c over x squared. That's if I square both sides. Therefore we have x minus a times x minus b, x minus c over x. That's 1x is gone. So I'm going to use this. So based on what we've analyzed, use it here. From there you can see that this length, this is equal to this, that's BE is equal to BF. And if the radius of the semicircle is R1, meaning that the length here will be 2R1. Yes. So I'm saying that here will be 2R1. And here again will be 2R1. Since the lengths are the same. That's R1 is the radius of the semicircle. They are the same. Why here? If here is R2, so here will be 2. The radius is R, so this is 2R2. This is also 2R2 based on the length from the external. Yeah, they have. Also here, if here is R, so meaning here is 2R3. Here is also 2R3. So from there you can see that if we call the length as, let AB be A, BC be B, and AC be C. That's A. That's A is AB, which is AB. A is 2R1 plus 2r2. YB, B, which is BC, BC is 2r1 plus 2r3. YC, C is AC, AC, which is 2r2 plus 2r3. So if you add this equation 1, 2, and 3. So if you add, because here we need to get the semi-perimeter. I told you X is the semi-perimeter. So if you add, if you now do A plus B plus C, which is equal to add, as you can see, we have 2r1, 2r, that's 2r1 here, 2r1 here, 2r2, 2r2, 2r. So you notice that 2r1 plus r, so both of them will have 4. So 4, you factor r1 plus r2 plus r3. Yeah, so if we divide by 2, which is now 2 r1 plus r2 plus r3. So this over 2 is now our semi-perimeter. Yes. From there, we can see if we now do each of the side, if we subtract it from the semi-perimeter. So if we do x minus a, x minus a is now this minus this. And if you do this minus this, is like 2r1 plus 2r2 plus 2r3. You see that this one contains r1, r2. So we are left with 2r3. The same way, if we do x minus b, where is b? So b has r1 and r3. So what will be left with 2r2. And x minus c is this. So we are left with 2r1. Yes. From here, you see that radius squared, from what I've used here, x minus a times that. So we substitute the values. So remember I said it's x minus a, x minus b, s minus c over x. So x minus a is 2r3 times minus b is 2r2 times 2r1 over x is 2 brackets r1 plus r2. And if you notice, 2 times 2, that's 1, 2 is gone. So we're left with 4 r1, r2, r3 over r1 plus r2 plus r3. So that's r squared. Let's call it equation 4. So from this, using the other theorem that the length of tangents here, the common tangent, if we now square, therefore L squared is now 4RR. That's squaring both sides. So we're going to use it. So from here you see that P squared is now 4 times R1 R3. Q squared is 4 times R1 R2. And x squared is 4 times r2 r3. So let's do the reciprocals. 1 over p squared plus 1 over q squared plus 1 over s squared is now 1 over 4 r1 r3 plus 1 over 4 r1 r2 plus 1 over 4 r2 r3. So from this, the LCM is 4 R1 R2 R3. So which is this divides that we have R2 plus this divide that we have R3. This divide this time. So we have R1. So from that, you can see that here R square is that. So if we do 1 over r squared is now r1 plus r2 plus r3 over 4r1, r2, r3, which is the same as this. So therefore, 1 plus p squared plus 1 over q squared plus 1 over s squared is equal to 1 over r squared. So that's how we generated the formula. That's the formula. So using these important theorems. So that's it. Thank you.